Example 2. Okay, the channel section shown in figure is subjected to a vertical shear force of V equals 7 kips. Calculate the horizontal shear stress at point A and the vertical shear stress at point B. Okay, here is a point A and a point B. Okay, again, the equation we'll use is just tau equals VQ over IT. Okay, according to the 4 steps we just introduced, we can just solve these 2 stresses step by step. Okay, step 1 will determine the shear force through this section that had been given. Right, the shear force V equals 7 kips or 7,000 pounds. Okay. Step 2, we'll calculate y bar and I. Again, I will just skip this. I believe you all have known how to use those 2 tables and 2 equations to calculate y bar and I. Okay, here the y bar is 0.657 inch from the top. Okay, from the top. Then if here is the centroid, here this is the y bar equals 0.657 inch. Okay, the I equals 2.3 inch to the 4th. Okay. Step 3, we will calculate the Q, and then we can calculate the tau at point A. So let's look at point A first. Right, so what is QA? Right, we're calculating QA. To calculate the QA, we just need to know the area and the dA. Right, but here, how can we cut the area? So as illustrated in the previous slide, for this kind of C-shaped cross section, if we're calculating the stress at this point A, then we'll cut this area, right, from here to a symmetric point on the other side of the centroid. Okay, we'll cut this area. Okay, not half it, not cut from the point to the y-axis. We need to cut it to the symmetric point on the other side of the y-axis. Okay, you get such area. So we can calculate the area here. So the A equals what? The A is just thickness times this point from this length from A to A prime. Okay, so that is thickness is 0.25, and the A prime is 4. Right, it's 4. The overall here is 8. So you have 2 on this side and 2 on the other side. Okay, so the middle will be 4. So here you get 1, okay, square inch. Then the dA will be the y bar minus half of the thickness. Right, y bar is 0.657 minus 0.25. This is the thickness over 2. Okay, so here you got a 0.532 inch. Okay, so your QA can be calculated as A dA. Right, that is just 1 times 0.532. That is 0.532 cubic inch. Okay, so now we can calculate the tau A. Right, the tau A is just VQ over IT. Right, the V is 7,000. Q 0.532 over I is 2.3. And T. Okay, here is let me ask you, what should we put here for the t value? The thickness here is 0.25. Should we use this number? Well, please recall the previous slide. Right, in this case, in the case of a C shape and such a point A, we need to use 2t. Right, this is 0.25 times 2. Okay. Then we can do this calculation. We got 3240 psi, or 3.24 ksi. This is the shear stress at point A. Okay, then the next step we'll look at point B. Okay, we're calculating the tall B. So first of all, we need to calculate QB. Again, here, if you need to calculate the stress at point B, you need to cut it from here, through here. Then you will get the area. That use another color. Okay, you will get this area. Okay, this case had been illustrated here. Okay, we'll just look at this sketch to do this calculation. Okay, obviously this shape can be divided into 3 sub areas: area 1, area 2, and area 3. Okay, we'll just calculate the QB by summing these 3 areas, summing this AD, 3 ADs. Okay, and area 2 and area 3 are the same, so you only need to calculate 1 and multiply it by 2. Then you get the result. Okay, so here, let's extend this equation. So you get, first of all, the A1, D1. So what is A1? A1, you have a thickness of 0.25, and the dimension along the x-axis will be 8. So the area 1, A1, is 8 times 0.25. And the D1, as we analyzed in step 3, the D is 0.657. This is the y bar, minus half of the thickness. Right. Here we got A1, D1. Okay. Later, we can calculate the A2, D2. Okay. This is the area 2. First of all, A1, A2. Right. A2, you get thickness that is 0.2. Right. So the length from B, this is B to B prime. This equals 0.657. This is y bar, right, minus the whole thickness, right, 0.25 of the top bar. Okay, this one times the thickness of the area 2, that is 0.2. Here you get the area. This is the area A2. Then what is D2? The D2 will be, since okay, the B is right on the z-axis, right? So the D2 will be from this global centroid to the local centroid of a sub area 2. Okay, here is the D2. Okay, so D2 can be calculated as 0.657 minus 0.25. This is the BB, right? The BB over 2. You get the D2. Okay. So here together, you get A2, D2. Then A3, D3 will be the same as this part, so just multiply it by 2. Okay. Then you get a QB, so that is 1.097 cubic inch. Then in the end, we can calculate the tau B, right? Just a VQ over I something. Okay, just a VQB over IT. Okay, here's a V. We already have the V value, that is 7,000 times QB is 1.097 over I, that is 2.3 times. Again, here we need a special value. Recall the previous slides. Again, you need 2 times, right? 2 times the local thickness. It is 2 times 0.2. Okay. Then you get the result. It will be 8,350 psi, or 8.35 ksi.